I want to show you how to solve a trig equation. This example is going to be a fairly easy one, and then we'll work our way up to more difficult ones in later videos. So here I want to solve 2 cosine theta minus square root of 3 equals 0, and I want to find all solutions, all values of theta that satisfy that equation that are also between 0 and 2 pi. So the first step whenever you're solving a trig equation is to get it in the form trig function of some angle equals a number. So the first thing we need to do here is solve for cosine theta. If we do that, we'll add square root of 3 to both sides. We get 2 cosine of theta is equal to the square root of 3. And then divide both sides by 2, we get cosine of theta is equal to the square root of 3 over 2. And now we have cosine of theta equals a number. So we should be able to use our unit circle to figure out which values of theta satisfy this relationship. Well, when is cosine of theta equal to the square root of 3 over 2? Well, that means that theta is equal to, square root of 3 needs to be the x value. The x value is the square root of 3 over 2 at theta equals pi over 6. Of course, there's another one around the unit circle where that's true. And let's see, it's going to be something pi over 6, but cosine needs to be positive, so it needs to be in the fourth quadrant. So I also want to consider theta equals 11 pi over 6. And those are the only two angles between 0 and pi over 2 that satisfy cosine of theta equals square root of 3 over 2. So here are my answers, pi over 6 and 11 pi over 6. And I've solved the equation. So it's really that easy. Now we can make it slightly more complicated if this angle is not just theta but something like 2 theta. So let's look at that now. Here I have almost exactly the same problem. The only difference is I have a 2 theta. And here is where we're going to have to add 2k pi to our angle and then figure out what k should be. So let me show you how that works. The first step is exactly the same. We want to solve for cosine of the angle. So we are going to do, well, when we do that, just like before, we'll end up with cosine of the angle, in this case 2 theta, is equal to the square root of 3 over 2. And now that should allow us to figure out what the angle is. The angle, 2 theta, just like before, could be pi over 6, or 2 theta could be equal to 11 pi over 6. The next step is going to be to solve for theta, so I'm going to need to divide both sides by 2. But before I do that, I must add 2k pi to both of these. Now normally I only add 2k pi when I want all solutions, not just solutions between 0 and 2 pi. But in this case, since I'm going to be dividing by 2, I'll also be dividing the 2k pi by 2, so I really only be adding k pi. I wouldn't know how many pi's I need to add unless I add this first. Alright, so from this, the next step would be to write theta is equal to pi over 12, I'm dividing both sides by 2, plus not 2k, but just k pi. And my second possible solution gives me 11 pi over 12 plus k pi. Now, this describes all solutions to this equation, but not just solutions between 0 and 2 pi. To find the solutions between 0 and 2 pi, I need to plug in values for k. So what could I plug in for k? Well, I could plug in k equals 0. That should work. And if k is 0, I get that theta is equal to pi over 12, and theta is equal to 11 pi over 12. But notice 11 pi over 12 is still just in the second quadrant. And if I add another pi to that, I'll still be less than 2 pi. So now I need to consider what happens when k is 1. So if k is 1, I get 2 more solutions. Theta could be pi over 12 plus pi. Pi over 12 plus pi would be 13 pi over 12. And if you don't see that, just write the common denominator for pi over 12 plus 1 pi. And if I add pi to 11 pi over 12, I get theta is equal to, let's see, 12 plus 11 is 23 pi over 12. And these are my four solutions. So my four solutions to this original equation on the interval from 0 to 2 pi are pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. And that's how you solve these simple trig equations. Hope this has helped, and thanks for watching.